morning, viewers. Welcome to MouShauk. Today, I will discuss the test for hydrogen, properties of hydrogen, and oxidation and reduction reactions. Okay. So, before I start, I will request you to please subscribe my channel if you have not subscribed yet, and if you are a new viewer to my channel. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And do meditate before you start your day. So for meditation, let us concentrate on the point of light for just 1 minute. And we will start with the discussion after this. So for meditation, please concentrate on the point of light. Think that light is falling on you. You're being enlightened. You're feeling that God is blessing you. God is being with you. Helping you in your every work you do. You're feeling interest. You're enjoying your work. You can easily solve your problems. And you can indicate you're getting success. You can easily provide. The dream begins the same day and supporting you in the future. Thank you. Thank you for continuing with the meditation. And let us start with the discussion. So in my previous video, we have discussed how to prepare hydrogen and why the preparation of hydrogen is needed. Okay. Now, how do we know that the gas which is being liberated after its preparation, that is hydrogen? So there has to be some tests to prove that the gas liberated is hydrogen. Okay, so what are the tests? This gas is combustible gas, but it does not support combustion. That is, it does not support burning, but it burns. Okay, and it burns with a pale blue flame. When it burns with a pale blue flame, it produces what? It produces water. Okay, so the reaction stands in this way that 2H2 plus O2 gives us 2H2O, that is water. Okay, now if it is pre-mixed with air or oxygen, then it can explode with a pop sound. That we can hear when we test the hydrogen in the laboratory. Okay. When we take the gas, when we take a burning splinter near the hydrogen gas in a test tube where we have reduced hydrogen, it will burn with a pop sound. This indicates that the gas which is being liberated is what? Is hydrogen. Okay, this is the main test. And it burns with a pop sound, but it is not a supporter of burn. Okay, now we come to the properties. That is, what is the nature of this gas? Nature of this hydrogen. Physical properties are this, that it is colorless gas. We cannot see any color of this gas, but it burns with a pale blue flame. Okay. It is odorless gas. It is tasteless. Okay. We cannot have any smell of this gas. We cannot have the taste of this gas. It's non-toxic. It's non-poisonous. And it is slightly less dense than water. It is 0.0899 grams per ml. Okay, it is the lightest known gas. It is 14.4 times less dense than air. Okay, and it's very slightly soluble in water. It's about 20 ml hydrogen dissolves in 1 liter of water. In 1 liter of water, only 20 ml of hydrogen will get dissolved. This gas can be liquefied at minus 240 degrees centigrade under pressure of about 26 atmospheres. 20 atmospheres. It can be under pressure if it is the atmospheric pressure is 20 atmospheres. If the gas is pressurized under 20 atmospheres, and the temperature is below -240 degrees centigrade, then the gas can be liquefied. It can be made into liquid. Okay, it is readily absorbed by palladium or platinum or nickel at room temperature. At room temperature, it can be absorbed by palladium or platinum or nickel. That is, 1 volume of finely divided palladium takes about 900 volumes of hydrogen at room temperature. Okay, and this absorbing power is known as adsorption or occlusion of hydrogen. Okay, so there is some experiment to prove that the hydrogen is a very light gas. Okay, it is the lightest gas I told you. So how much, to prove that this is the lightest gas, there is an experiment to show that. What is that? If we take a glass bottle, where we take some granulated zinc and pour some dilute hydrochloric acid through a twistle funnel into the bottle, the granulated zinc will liberate what? The reaction will take place with the dilute hydrochloric acid, and the hydrogen will be liberated. And if this hydrogen is passed through soap solution, the hydrogen gas will come out as bubbles. So when it is passed through soap solution, the hydrogen gas will take the soap, the soap bubbles, okay, will be filled in the soap bubbles, and the soap bubbles will become lighter, and they will fly away in the air, rise upward in the air, this shows that hydrogen is a very light gas. Clear? Next, we come to some chemical properties. Okay. The chemical properties of hydrogen are divided into 4 major topics. So what are those? Reaction with non-metals, reaction with metals, reaction with metal oxides, and some organic compounds. Okay, reaction with some organic compounds. So let us study one by one. First is reaction with non-metals. Non-metals like oxygen, then chlorine, then nitrogen, then sulfur. These are all non-metals with which hydrogen reacts, forming some compounds. With oxygen, it burns in oxygen in the presence of electric spark. Electric spark is required for the combination of hydrogen with oxygen. That is, it burns in oxygen in presence of electric spark to produce what? Produce water. Okay, when it is burning in oxygen in presence of electric spark, it produces a pale blue flame. But when there is no oxygen, when there is no impurities in hydrogen, when it is pure hydrogen, if we use, then we will get what? We will get the burning of hydrogen will be very quiet in the air. Okay, the hydrogen will burn in air very quietly. Clear? Next, hydrogen and chlorine. Hydrogen combines with chlorine, that equal volumes of hydrogen combines with equal volumes of chlorine to form what? Hydrogen chloride in diffused sunlight. It's a very slow reaction. It's a slow reaction where hydrogen combines with chlorine in diffused sunlight. But one thing, equal volumes of hydrogen has to be taken with combined with equal volumes of chlorine. Okay, and again, equal volumes of hydrogen combines with equal volumes of chlorine in direct sunlight, then the reaction becomes explosive. Again, hydrogen chloride is formed, but the reaction is explosive. Only in diffuse sunlight, the reaction is slow reaction, but in direct sunlight, this reaction becomes explosive. Why this reaction becomes explosive? Because the reaction takes place is spontaneous reaction and highly exothermic reaction takes place. In direct sunlight, this reaction becomes highly exothermic and spontaneous reaction. That's why the reaction becomes explosive. Okay. Now, hydrogen combines with nitrogen. That is, 3 parts of hydrogen combines with 1 part of nitrogen in presence of finely divided iron as catalyst and molybdenum as promoter in either under a temperature of 450 to 500 degrees centigrade and 200 to 900 atmospheric pressure to form ammonia. To form what? To form ammonia. This is the Haber's process. Okay. So 1 part of nitrogen combines with 3 parts of hydrogen in presence of iron, finely divided iron as catalyst and molybdenum as promoter. Okay. And the temperature should be 450 to 500 degrees centigrade and atmospheric pressure should be 200 to 900 atmospheric pressure to form ammonia. This reaction is a reversible reaction. If the conditions are reversed, then again nitrogen and hydrogen get separated. Okay. And another thing, catalyst we know that speeds up the reaction. So iron acts as a catalyst here. Iron speeds up the reaction and promoter molybdenum that adds to the speed of the iron. Okay, that means it speeds up the reaction of the, the action of the catalyst. Okay, it speeds up the action of the catalyst. That is double speed it occurs and the is given to the reaction of nitrogen combining with hydrogen and ammonia is being formed. Okay, this is Haber's process. Next is hydrogen combines with sulfur. That is, molten sulfur is required to combine with hydrogen, and what is formed? Hydrogen sulfide gas is formed. Okay, it smells of what? Smell of rotten eggs, which indicates that it's hydrogen sulfide. Okay. Now, hydrogen combines with oxygen. We know this mixture is formed combining, hydrogen combines with oxygen. We know that should be an electric spark given. Okay, but when this hydrogen combines with oxygen, it forms a mixture which is known as detonating mixture. It's a detonating mixture. Okay, hydrogen burns in oxygen. That is, impure hydrogen burns in oxygen to form a blue flame. Okay. And it burns silently if there is no impurity. But if there is some impurity present in hydrogen, then what happens? Then it forms a pop sound. Explosion, it takes place, and it is a pop sound appears when hydrogen burns in oxygen. Then see, the reaction is like this. It is made anhydrous. It is free. Hydrogen is made free from water. Okay, so that we can get the water. Hydrogen, when combines with oxygen, it forms water. Okay, so first, when hydrogen gets inside this reaction, we take a U tube, okay, in which hydrogen is passed through. Moist, pure hydrogen is passed through. Other impurities are removed, only moisture is there. So that is absorbed by the anhydrous calcium chloride. And what happens? The gas which is passing through contains only pure hydrogen without any moisture at all. Okay, so that will burn in oxygen. I'm sorry, I told you that impure hydrogen burns in oxygen to give a blue flame. Hydrogen burns in oxygen to give a blue flame. Okay. Now this pure hydrogen burns in oxygen to form a blue flame, and this gas comes out, water vapor comes out, and this water vapor condensing, forming water, condenses to form water, which is collected here. Okay. So this is the experiment shown of hydrogen combining with oxygen. Okay, diagrammatic experiment. Then we come to the second reaction, that is reaction with metals. Metals like potassium, sodium, calcium, okay, These are combined with hydrogen to form their hydrides. Okay. For potassium, potassium combines with dry hydrogen in presence of heat to form potassium hydride. Sodium also combines with dry hydrogen to form sodium hydride. Calcium with hydrogen forms calcium hydride in presence of heat. Okay. They react with these hydrides, they react with water to form hydrogen. Okay. They react with water to form again hydrogen. Okay, so this reaction stands like this way, that is 2K plus H2 in presence of heat forms 2KH, 2Na plus H2 in presence of heat, 2NaH, Ca plus H2 in presence of heat forms CaH2. And this CaH2, calcium hydride, combines with water, 2H2O, to form calcium hydroxide, and 2H2 is liberated. Okay. So hydrogen is given back. Next is reaction with metal oxides. Now, hydrogen is a strong reducing agent. It will remove oxygen from the metal oxides, and will reduce the metal oxide to its metal respective. Okay. This can be understood by the color change. The colored metal oxides, the color of the metal oxide changes to some different color of the metal. Changes to the color of the metal, okay, in presence of heat. So the general reaction is metallic oxide plus hydrogen in presence of heat forms metal and H2. Okay. So for example, Fe2O3 plus 3H2 will give us 2Fe plus 3H2O. Here the brown color of ferric oxide. The brown color of the ferric oxide changes to gray. Okay. Then again, Fe3O4, that is tri-iron tetroxide, that also combines with 4H2, that will be reduced by 4H2 in presence of heat to Fe, 3Fe plus 4H2O. So Fe3O4, tri-iron tetroxide, is also brown in color, and that color changes to gray after it is reduced to iron by hydrogen. Then yellow color of lead monoxide, that will combine with hydrogen, that will be reduced by hydrogen to lead, that is to silvery gray color lead metal, and water will be given out, produced. Then black copper oxide, that also will be reduced by hydrogen to copper, reddish brown copper, and water will be given out. Okay. Now the reaction with organic compounds, that is known as hydrogenation. The reaction with organic compounds is known as hydrogenation. This here in hydrogenation, what happens? Hydrogen will combine with some double bond and triple bonds of carbon to give their single bonded carbon atoms, and this is known as hydrogenation. Okay, so ethylene is a double bonded carbon compound. CH2, double bond CH2, that will be reduced by hydrogen to form ethane, single bonded C2H6, ethane. This is a direct combination. Again, direct combination, it directly combines with acetylene to form C2H6. CH, triple bond between. That is C2H4 will be formed to C2H6. Okay. And in the previous one, C2H4 will be reduced to C2H6. Okay. Next, hydrogen does not react with blue or red litmus color because it is neither acetate nor basic. That's why it does not react with blue or red litmus. Okay. Now we come to some redox reaction. What do you mean by redox reaction? where in the reaction or the chemical change where oxidation and reduction takes place simultaneously. Now, what is oxidation? What is reduction? Oxidation is a chemical reaction in which oxygen is combined to the substance wholly or partially, or if hydrogen is being removed from it, from some of its compounds, or electronegative ion is combined, added, or electropositive ion is removed, or there is a loss of electron. Okay. So if there is a loss of electron, then also what happens? There is oxidation. Okay. So what happens? For example, element combines with oxygen to form oxide. This is oxidation. That is, therefore, carbon combines with oxygen to form carbon. Okay. Or you can say H2S plus chlorine. Second, that is when hydrogen is removed, then it is oxidized. So hydrogen sulfide is being oxidized to sulfur and chlorine itself gets reduced. So this is a redox reaction taking place. See, one compound is being oxidized, another substance is being reduced. Okay. So here, what is happening? Hydrogen is being removed. Okay. Then zinc plus hydrogen chloride. If an electronegative ion is added, then it is also an oxidation reaction. Okay. So here, zinc, chlorine is an electronegative compound, electronegative ion, and that is added to what? Zinc. So zinc is being oxidized. Clear? Next, potassium iodide. Here what happens in this reaction, there is removal of electropositive ion. What happens? Potassium iodide, potassium is a electropositive ion, is an electropositive ion. This potassium is removed and iodine is separated. So iodine is being oxidized. Okay. So there is a loss of potassium ion, electropositive ion, potassium ion to make iodine as oxide. Iodine oxidized. To oxidize iodine. Okay. So potassium iodide combines with hydrogen peroxide H2O2 and 2KOH is formed, potassium hydroxide and iodine is oxidized, I2. Now hydrogen readily combines with oxygen forming water. Hydrogen readily combines with oxygen to form water, which regarded hydrogen as a kind of opposite, chemically opposite of water. Opposite of oxygen. Chemically opposite of oxygen. Oxygen is oxidizing, adding oxygen. Okay, it's oxidizing, and hydrogen is, the properties are totally opposite of oxygen and hydrogen. That is, it's considered as a kind of chemical opposite of oxygen. Hydrogen is the chemical opposite of oxygen. Okay. Now, oxidizing agents, it is one that oxidizes other substances either by accepting electrons or by providing oxygen, or an electronegative ion, or by removing hydrogen, or an electropositive ion. That is oxygen here, chlorine, hydrochloric acid, hydrogen peroxide, these all are oxidizing agents. Either they are adding oxygen to it, to the substance, or they are removing hydrogen atom, hydrogen from the compound, or they are adding electronegative ion, or they are removing electropositive ion. So therefore, these all are oxidizing agents. Solid examples of some solids which are oxidizing agents like manganese dioxide, red lead, then lead dioxide, potassium permanganate KMnO4, potassium dichromate K2Cr2O7, bleaching powder, etc. These are all solid oxidizing agents. Some liquid oxidizing agents, hydrogen peroxide, concentrated nitric acid, concentrated sulfuric acid, bromine, etc. These are all liquid oxidizing agents. Then gases, some gases oxidizing agents are oxygen, ozone, chlorine, sulfur dioxide, etc. Okay? So if an atom or electron is being lost, then also what happens? The reaction becomes oxidized. Okay. So oxidation reaction. Okay. So zinc loses 2 electrons to form zinc 2 plus ion. Then therefore it is losing 2 electrons. So this is an oxidation reaction. Okay. Now we come to reduction. A chemical reaction in which there is removal of oxygen, removal of any electronegative ion, addition of hydrogen, or addition of an electropositive ion, or gaining of an electron. If you gain an electron, then also it is a reduction reduction reaction. Okay. For example, when oxide is added to the element, it becomes metal oxide. It becomes metal oxide. Okay. Okay, sorry. Oxide is added with the hydrogen is being added to the oxide, then it becomes metal. Okay, it is reduced to metal. So what happens, for example, copper oxide, when hydrogen combines with hydrogen, then copper is formed. From black copper oxide, the brown metal, we can get the reddish brown metal of copper and water will be formed. So the metal oxide reduces to metal. There's a reduction reaction. Then ferric chloride, FeCl3, combines with H2S. Okay, what happens here? One electronegative ion is being removed. So FeCl3, Cl3, 3 chloride ions were there, and the formation of the ion is, formation of the compound is FeCl2. So one chlorine ion is less in the ferric chloride substance compound. Okay, so the ferric chloride is reduced to ferrous chloride and HCl is formed and sulfur. Okay, so here you can see iron chloride, ferric chloride is being reduced to ferrous chloride. Okay, and one chlorine ion is less. Okay, and sulfur is being oxidized, and again chlorine here is being reduced. Okay. So simultaneously, oxidation and reduction reactions are taking place. Then here ammonia. Okay. What happens here? Hydrogen is being removed from nitrogen. So nitrogen is being, hydrogen is being added. Sorry, nitrogen is being oxidized. Hydrogen is removed from nitrogen. So nitrogen gets oxidized and chlorine gets reduced because hydrogen is added to chlorine. Okay. So addition of hydrogen to chlorine becomes reduction reaction for chlorine. Okay, so chlorine gets reduced here to HCl. Okay. Then mercury chloride HgCl2 and stannous chloride. Okay, the stannous chloride, excuse me. Electropositive ion is being added here. Okay, so what is the electropositive ion here? Electropositive ion is Sn. Okay, or Ag. These are electropositive ion. Electronegative ion is Cl2, Cl2, Cl2. These are the electronegative ions. Okay, so we can see here that this stannous chloride is adding mercury to mercurous chloride and making it mercurous chloride, making it Hg2Cl2. One mercuric ion is added here. It is this SnCl2 helping one mercuric ion to add here add in this HgCl2, making it Hg2Cl2. Okay, so HgCl2 is being reduced. Okay, adding of HgCl, Hg2 will be reducing Hg2, reducing Hg to Hg. Clear? Next is cupric, cupric ion. Cupric ion will gain 2 electrons to form copper. Cupric ion Cu2 plus ion will gain 2 electrons to form copper. Okay. Now reducing agents. Reducing agents are what? Reducing agents are one that reduces other substances either by giving electrons, by giving hydrogen to it, or removing one electropositive ion, or by removing oxygen. Okay, providing hydrogen or electropositive ion, adding electropositive ion, or removing oxygen, or removing electronegative ion. Therefore, here in these all the reactions above, H2, carbon, that is hydrogen, carbon, stannous chloride, sulfur, hydrogen sulfide, ammonia, all these are reducing agents. They are reducing the substances. Now, solid examples of this reducing agents are carbon, metals like zinc, copper, and sodium, stannous chloride, glucose, etc. These are all what? These are all solids which are reducing agents, rather examples of solid reducing agents. Some liquid reducing agents are hydrogen peroxide, hydrogen iodide, hydrogen bromine, etc. Then some gases. Some gases are hydrogen sulfide, carbon monoxide, SO2, ammonia, etc. These are some reducing gases. Okay. Next, if one substance is oxidized, okay, so therefore, what is the redox reaction? One substance is being oxidized, the other substance must get reduced. And simultaneously, this will happen in the chemical reaction. So this is a redox reaction. Why this happens? Because the electrons lost during oxidation, electrons that are lost during oxidation are simultaneously gained during reduction, and vice versa. Electrons that are lost during oxidation, it's not lost, but it is lost. Lost during oxidation. During the oxidation process, the substances that will lose electron will be gained by some other substance. So both the processes occur separately. Same way, if there is a reduction, when when a substance is gaining electron, it will lose, some substance will lose electron. So like this it happens. For example, copper sulfate plus zinc gives us ZnSO4 plus copper. So copper sulfate you can write in this way, Cu2 plus SO4 2 minus plus zinc will happen like this. Zn will lose 2 electrons to form Zn2 plus, and SO4 2 minus will be added, and Cu2 plus will gain 2 electrons to form C. Okay. Zn will lose 2 electrons to Zn2 plus, there is oxidation taking place, and copper Cu2 plus ion will gain 2 electrons to form copper. This is the reduction. Okay. So oxidation and then reduction. Again, CuO plus H2 gives us Cu plus H2. So CuO will be get reduced to copper, and H2, that is the reducing agent, will be get oxidized to water. CuO is an oxidizing agent. Okay, it will oxidize hydrogen, and hydrogen is a reducing agent. It will reduce copper oxide. Then hydrogen sulfide is a reducing agent. It will oxidize sulfur. Okay, it will oxidize sulfur. It will take away the hydrogen from sulfur. And chlorine is an oxidizing agent. Chlorine is an oxidizing agent. It will reduce the hydrogen. It will reduce the chlorine to hydrogen chloride. That is, it will add hydrogen to help in the addition of hydrogen to the chlorine. So it will be get reduced to hydrogen chloride, and as this is an oxidizing agent. Clear? That is, as this is an oxidizing agent, it will reduce hydrogen sulfide with sulfur, and hydrogen sulfide, as it is an reducing agent, it will oxidize chlorine. Sorry, it will, as this is a reducing agent, it will reduce chlorine to HC. Clear? Any doubt, please to write in the comment box, or you can also write in my email ID, that is kasturi74@gmail.com. This is the end of the chapter. Please go through all the videos. If you have any doubt, please to write in the comment box or in my email ID. Please to subscribe if you have not subscribed yet, or if you are a new viewer to my channel. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And do meditate before you start your day. Do make a chart at the beginning of the day, what you want to do the whole day, and then work accordingly. And at the end of the day, check it up, how much you have completed, and plan for the next day. Okay, this will help you in keeping a track on what you are doing, how you are preparing yourself for your exams. Okay, so till then, bye-bye, and do meditate before you start your day. Thank you for joining. Have a good day.